How to create a VAV box in PractiCAD catalogs. In this tutorial, we're going to focus on designing a VAV box. There are multiple types that PractiCAD offers. Today we're going to design a standard Titus DESV directly off of a submittal sheet. To start the catalog, we're going to go into My Library. Here we're going to show you the path that you need to get to in order to open up the VAV options. Underneath Ductwork, Library Auxiliary, underneath Rectangular, Other, we have a list of air handling units and VAVs. In this tutorial, we're going to use the SD VAV box round, which means the round inlet, with straight. This is one of the most common VAV types out there, so it's the reason why we're choosing it for this particular tutorial. You can see that this particular system already has a lot of VAV catalogs that have been created. We're going to create a new one, and we're going to do it based off of this submittal sheet. So we are going to go back and forth between pages, but this is a standard Titus DESV VAV box. It has a diagram, and it's got all of the parameters that we need. Now VAVs have a lot of parameters, so the reason why we created a tutorial is just to kind of help you figure out some of the formulas you'll need to know in order to calculate parameters that are not given to you, particularly offsets. Going to go back into my AutoCAD. We're going to first hit Create a New Catalog button. Then what we're going to do is we're going to name this PCAD Titus DESV. Once again, I like to use capital letters for my entry here, just in case I need to report this later. I like to keep the format consistent. Now what we're going to do is we're going to create a new item. And we're going to name that item 4-inch. And then I'm going to type in Titus DESV. And I'm going to copy everything that I'm going to use over again. I'm going to hit Control C. And now we're going to come over to the property box. I'm going to open this window as well. And I'm going to kind of open the browser a little bit more this way so that we've got more space. Here we have a preview of the fitting. And this preview is very important in order to figure out what parameter goes where. It's easy to find out what parameter the width out is because you just highlight the parameter and roll with your mouse, and you can see obviously that that is the width out. So we're going to go over each property one at a time. We're going to go to our submittal sheet, and we're going to start here on this diagram. We can see that we've got W. W is going to be the width of the body, and H is obviously going to be the depth of the body of this fitting. There is no straight out here that's indicated. This is the connector, but if there were, we'd probably put a little parameter for straight out as well. So we're going to start. We can see W. Here we have the width of the body is 12 and the height is 8. And the width out and depth out are going to be the same as we can see here in this submittal. So we're going to come in and say width out will be 12, depth out will be 8, width body 12, depth body 8. Now we come to tap diameter. Tap diameter, we're actually going to use the nominal size. And the reason why we're using nominal size is this is the way that companies order their VAVs. Also, when we go to attach objects in PractiCAD, if it's a 3.75 actual, but we want it to report as 4, if we actually put it as 3.75, it will report as a 3.75. Also, when duct attaches to that inlet, the duct is going to be 3.75. So we're actually going to use the inlet size listed here rather than the actual diameter. You could do either one. Most of the time, companies will use the inlet sizes. So we're going to say that the diameter here is 4. So come to tap diameter. We're going to put 4 in for that property. Now we need to go to the property length. And this, as you can see, is obviously the length of the body of the fitting. So we come to the submittal sheet. We can see here that the length of the body of the fitting is indicated by L. And under my 4-inch, I'm going to go to 15.5. So going back, we're going to type in 15.5. Straight out, dependent upon whether it does have a little straight out or a connection, this might vary. In this tutorial, I'm actually going to create the straight out and just make it 0. But you could add a little straight out. Often, as a hint, companies will create the same VAV catalog and they use the straight out for the coils. Sometimes they'll copy it and use it for the coils, so that's just another idea. You could always add distance to the straight out, or you could add the length of the coils to the length and have two catalogs, one with coil and one without. In this tutorial, we're going to keep the length back at 15.5. We're going to go from straight, and now we're going to go to offset. You can see here that this offset is actually just the width out and depth out as I move it up and down. So we're going to keep that at 0. The inset is just the up and down properties of the width out and depth out. Here it's the same, so once again we're going to leave it at 0. Tap length should be indicated on our PDF submittal. You can see here the tap length is going to be indicated by the property M right here. So it's going to be 5 3/8. And here you can see we actually already have 5.380. And keep in mind, we can type in as many decimals as we want. Right now we've got our AutoCAD format set to decimal, and we have the precision set to 3 zeros. This allows us to type in values like 5.375. If in fact my format was set to decimal and my precision was set to 0, we would end up getting rounded numbers when we typed in 3 digits. That's why when we go to create catalogs, it's important to change the format and precision. There are instructional videos on that. You go to the AutoCAD menu, format, and change the units there. Now we've got tap offset, and this is the one we're going to focus on. Tap offset is the distance that this tap will be offset from the end of the fitting. An easy way to figure out how this works is to put the fitting in left view. And then what we're going to do is zoom in. You can rotate, orbit this fitting, choose the different views, so you should utilize this to your advantage. Here you can see that if I set the tap offset to 0, you can see that it moves it to the edge. So to calculate the formula to make this tap offset is obviously the offset left to right. And the formula to calculate this number here, I've put in notes. Tap offset actually equals the width of the body of the fitting minus the diameter of the tap divided by 2. And this formula will give you a tap offset that's perfectly centered. So once again, I'm going to take the width of the body of the fitting, which is 12. I'm going to subtract the diameter of the tap, which is 4. And then I'm going to divide it by 2. And that's going to give us the property 4. And if I put in 4 here, you'll see that that's actually perfectly centered left to right. Then we've got tap inset. Tap inset is controlling it up and down. And in this tutorial, this particular VAV, it's centered. And it's the same thing. Here, the formula for tap inset is actually the depth of the body minus the diameter divided by 2. The depth of the body minus the diameter of the tap divided by 2. So you can see depth of the body is 8. So we'll put in 8. We know that the diameter happens to be 4, so we're going to say minus 4. And then we're going to divide this by 2. And that's going to give us the 2 value that we need. And you can see this tap is now perfectly centered. Next, what we're going to do is go to width. Width is going to be the actual length. And notice it says width 1 here and length 2. Sorry, length 1 and length 2. Length 1 is the length of the box. You can have multiple boxes. You'll see that we can create multiple boxes. Not just one, but 2 boxes in the program. If we set the values of length 2 to 0, length 2, width 2, and depth 2, also offset 2, it'll only give us 1 box. And in this submittal, we only have 1 control box here, so that's what we're going to use. So let's put this in front view. We want to control the length of this box. And you can see here by clicking on length 1, it's getting larger and smaller. We're going to go over to the submittal sheet. And the length, obviously you can see that the depth of the box, or the height, is 12.25. You can see that the control box is 6.5 inches wide. And you can see that the length of this is 18 inches. It's marked right here, 18 inches for the control box. So that's going to be our length 1. Length 1 will be 18 inches. So we're going to say length 1 is 18 inches. width one is actually 6.5 inches, and the depth was 12.25 inches right here. So we're going to take the depth and say 12.25. That is the control box. Now we have the offsets. As you can see, once again, if I set offset to 0, I can see that that means how far this is from the edge. And in our submittal sheet, there's a parameter right here, G. And G is telling us how far we need that offset to be. And G for 4 inches, 7 3/8, so 7.375. We're looking at parameter G, and that is the distance right here. So we look at the submittal sheet, it says 7 3/8. I'm going to come into my offset 1, and I'm going to put in 7.375. And now we've got the correct offset. Inset, if we just kind of roll up and down, we can see that obviously moves the control box up and down. If the inset is 0, we can see that it's working right off the top. So once again, it's always good to set the insets and offsets to 0 first and then see which direction they're moving. And here I believe they're actually giving us the parameter. It's the value F, and F is 2 1/8. So it's on the submittal sheet. So we're going to say F, which is this little parameter right here, and we're going to say that's 2 1/8. And that's going to be our inset 1, 2.125. And that should be perfectly centered if we've offset this correctly. So now what we're going to do is put it in a front view. And you can see that it is centered, the tap is centered, and everything's set here correctly. So the next step is going to just be to complete the remainder of the parameters. We've got here length 2, width 2, depth 2, and offset 2, also inset 2. As we said, we set them all to 0 because we don't want 2 control boxes, but you can have 2 control boxes. Whole width, whole depth, whole offset, and whole inset are only parameters that have to do with fabrication. 99% of all contractors using the program are not creating their own VAVs. But PractiCAD does allow you to download these VAVs. These parameters are almost always going to be set to 0. Then we've got side. You can put this control box on any side you want. And this can be controlled after you put it on the screen. But you can say that I would like my VAVs to have it on the far side as opposed to the near side. The way we dictate near and far is that if airflow is going through the inlet, the near is on the right side. Far is always on the left side. It is about airflow and the connection in. Connector in dictates if the airflow is always going through the connector in, near is on the right, far is on the left. Top is top and bottom is bottom. Here we're going to set it for far. Then I'm going to give it a material, my gauge. These are fabrication parameters, so they're not necessary. Connector in, I'm going to say raw edge, but you might want to use a crimp. This is all dependent upon the contractor's choice for connectors. The connector out I have set here as slip and drive. We're going to give it an airflow. This is something that can be controlled on the fly. So I'm going to say 200 CFM, but actually it's probably good to set this CFM to 0 and then input it as you put the VAVs down. Or you can actually see that the CFM range is here. Possibly you want to pre-input that CFM range. That's what airflow is for. You got the ability to put in a model number. Fabrication can be download to plasma, cut and label, or order. And of course, if you'd like it lined, you could line it. Lining it will actually line the outside, and when you attach to it, it can line duct. So you can add liner or insulation. Once we've created one VAV, what we're going to do now is just highlight the one we've created and copy it. Then we're going to type in 6-inch VAV, and we're going to start this process over again. The good thing is, though, a lot of these parameters are going to stay the same. We're probably only going to change the tap diameter, and we have to pay close attention to the offsets. As we go through this, we would then have created our PCAD Titus catalog. So what we're going to do is I'm going to drag this catalog into my bin and drop it here. And now we can exit out. Notice that it's telling me to save changes. I'm going to say yes. And now we can go into our bin, open up our new catalog, and here we're only going to have 2 choices, 4-inch Titus DESV and 6-inch. But we can pick the 4-inch, place it on the drawing, and this is going to save a lot of time by cataloging this entity. That will conclude how to build a VAV catalog.